Hello and welcome to the eTech podcast with me, your host, Ryan Maughan. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts, as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world.
So for today's episode, I've been joined by Richard Clarke, who is the Principal Mechanical Design Engineer at McLaren Applied. Welcome to the show, Richard. Thanks for joining me.
Thank you. Welcome.
And I wonder if we could just start by finding out a bit more about you and your background.
Sure. So I suppose a lot of people ask me why I'm an engineer. It's sort of baked into me a little bit, I suppose, but it's something I've always been interested in. My dad's an engineer. Both my grandparents are engineers. My dad's recently retired after 40 years working for the same automotive company. So it's always been there or thereabouts for me. I grew up just outside Birmingham in Solihull. I went to school up there my whole life. All my family and friends still live up there, which might give you a clue who my dad used to work for.
Yeah.
And then, so when I was at school up there, classic engineering subjects, maths, physics, a little bit of design technology, spread out into a little bit of art to try and cover that creative side as well. And really just what I would say is followed a relatively traditional route nowadays. So did my A-levels, and then ended up going to university to do an undergrad master's. I went to the University of Bath to do that. Chosen for a few reasons. One, primarily because they're a great engineering university. Secondly, slightly selfishly, they've got a very good rugby program, and that was a big interest for me at the time.
They do. Very good at sports there. Very good.
Yeah. So I was there for 5 years. Loved my engineering. It was, for me, never going to be anything other than engineering.
So was that at Bath? Would that have been, because they've got quite a wide range of different courses? Did you do pure mechanical, or was it a sort of specialism?
Sure. So ultimately I did pure mechanical, but for the first 18 months, 2 years, they bundle a lot of engineering courses together. So that would be automotive engineering, motorsport engineering, even medical engineering, all into the same first couple of years to get your base level of maths and physics up, do some core subjects. I think there was pushing over 250 students in those first few years before you then in your penultimate and final year start to pick your specialisms, and that's where you really start to zone in. Ironically for me, I didn't want to pigeonhole myself with an automotive or a motorsport degree, but I actually ended up choosing all the modules that meant I effectively did that anyway.
Yeah.
And I think I did that because at the time I wasn't 100% sure where I wanted to end up. And I think a lot of people are in that same boat there. And I felt like a mechanical engineering degree had enough variety and didn't, even just from title, pigeonhole me too much.
Well, you can study mechanical engineering and be an accountant if you really wanted to.
Exactly. I have many friends who did that. So yeah, engineering is a great way to get into many industries because it just demonstrates key skills in problem solving, comfortable with numbers, those sort of skill sets that a lot of employers look for. I actually took a year out in the middle of my university. So that was a formal, what they call a sandwich year. So I did 2 years at university, a year in industry, and then 2 years at university. The year in industry was working for a small firm up near Coventry, who actually made machines that made other things. So mostly in FMCG, so not motorsport at all. So fast moving consumer goods. So all the things that you buy in your weekly shop have to be made or packaged or manufactured somewhere. And this company made the machines that do those things. So somewhere there's a big machine that makes tea bags for you. Somewhere there's a big machine that makes deodorant cans for you. All those sort of things, which was very interesting. And I did that for 12 months and then went back to university. And it was great. And it confirmed to me that engineering is where I wanted to be. And then I graduated in 2010 with a 2-1 engineering degree from the University of Bath, which is a great thing to have on my CV for me and looking at potential opportunities. Unfortunately, 2010 was peak recession, and a lot of companies were not employing at that time. Luckily, I landed on my feet and got a graduate role with Dyson, who were very, very hot on their graduate recruitment, even during that period in time. So I met and worked with some great engineers whilst I was there, working on vacuum cleaners, hand dryers, dealing with mass manufacture of plastics, all the way through to developing products with an aerodynamic acoustic lean on them. So, for example, trying to make the products quieter. So I learned a lot whilst I was there. And I was there for nearly 4 years, I think. I spent a little bit of time in their reliability team as well, which was very interesting. But ultimately, I got to a point where I possibly fancied a new challenge. But if I'm being brutally honest with anybody, me and my long-term girlfriend, now my wife, decided that we should probably live together. And we were opposite ends of the country.
Yeah.
So we both looked for different jobs at the same time. And that was when I came across a job at Redbull Racing to work in their aerodynamics department. And I couldn't turn that down.
It's a pretty cool job.
I've always loved cars. I've always enjoyed motorsport. So to have an opportunity like that, and at the time, so that was late 2012, early 2013. By the time I'd made the move, it was sort of mid 2013. Red Bull could do no wrong. So it was a great environment to go into. That was towards the back end of their championship winning years with Sebastian Vettel. So to get involved with those guys, clearly some of the best in the business, to learn from. I learned so much whilst I was there. Won world championships, which is a great feather to have in my cap. But predominantly worked on the wind tunnel model and the aerodynamics. So worked closely with aerodynamicists who were doing the computational fluid dynamics. But spent the majority of my time developing components to go on wind tunnel models, which have slightly different requirements to F1 cars. So you need to have very, very quick turnaround to do iterative testing. You also need very accurate equipment, such as I designed some of the load cells that go on the wind tunnel. So they're actually the devices that collect the data. Also had the joy of working with Adrian Newey a little bit as well. There was a small group of us. Part of our role was to take his hand-drawn sketches and turn them into 3D CAD that we could then run through CFDs and develop into wind tunnel models. So that was very eye-opening to see. I mean, everybody knows what his success is like in Formula One.
So genius at work.
Yes, it's unparalleled, really. So having the opportunity to work with somebody like him was pretty special. But also the team there. I mean, the entire aerodynamics team were phenomenal when I was there. And I think testament to that is how far they've spread amongst the F1 community. If you look at a lot of F1 teams now, most of them, I know people who work in most of those teams, particularly from aerodynamics. And yeah, that was a privilege to work with a lot of those guys. And then really my next step was coming across to McLaren, who were McLaren Applied Technologies at the time. Really, I was looking for an opportunity that wasn't necessarily motorsport at that time. I loved my time at Red Bull at motorsport, and I was in my late 20s and I wanted to see what else was out there. The McLaren Applied Technologies actually offered a really interesting route there, which was a company that's born out of motorsport background. But actually, at the time, they were doing lots of really interesting things. So I got to work on, when I first started, medical projects, for example, projects that not many people appreciate that McLaren Group have been involved with, whether that be exoskeletons for different medical reasons, measurement devices to assist with post-operative care with patients, for example, knee wearables, let's say, and lots of other stuff that I probably can't talk about. There are some really cool projects that team have worked on in the past. So it was definitely a step away from motorsport, but McLaren Applied appealed to me because of that motorsport mentality that still existed.
It's like one toe in the motorsport world and one toe out kind of thing.
Yeah, exactly. So I mean, McLaren Group, as it was called at the time, is formed of three key companies: McLaren Racing, which is their Formula One outfit; McLaren Automotive, which is their road car segment; and then McLaren Applied Technologies, which basically did everything else if it wasn't those two. it stemmed. McLaren Applied Technologies is now called just McLaren Applied. It rebranded a few years ago. But McLaren Applied Technology has been through a number of names, starting off as Tag Electronics over 30 years ago, all the way through from McLaren Electrical Systems Limited, through to McLaren Applied Technologies, through to the McLaren Applied we know today. And that stemmed from initially Tag Electronics was predominantly electronics. They were doing motorsport electronics for the Formula One race team. And that just grew and grew and grew just because of, obviously I wasn't around at that time. There are still guys here who were around at that time and still work here, which is testament again to McLaren Applied as a company. So for my first, let's say 3.5 years, McLaren Applied, I was working on the non-motorsport, non-automotive projects. I did dabble a little bit just because of my background, but my focus was the design side of things. So let's say the medical projects, the things that outside of these four walls people aren't really aware of, which was really interesting for me. But over COVID, I think the world changed a lot. McLaren Applied was not immune from that. Everybody had difficult times, but that was the time when McLaren Applied was effectively sold by McLaren Group to a private investment group. And the focus there was, I think, partly because of private investment group and partly because of the state of the world at that time. Let's focus on what we're great at. And at the time that was motorsport. We also have some pretty large automotive projects going on, and the focus of those is really taking our motorsport heritage and knowledge and applying those into automotive sectors, typically inverters for us. So we do a lot of work with inverters. And then we also have a third section in the company at the moment called Connected Intelligence that are applying a lot of that know-how into the rail industry, which I don't know a lot about, but it's not really my sector. Those three sectors operate relatively independently now. We're starting to share a little bit more, but my focus is within the motorsport business. And I work within the motorsport business for an area of McLaren Applied called high performance components. And that's been around for a very long time, servicing teams. So we design, research and develop, manufacture and test and support sensors and alternators, which fall into that bracket, for pretty much any motorsport series professional you can think of anywhere in the world. So whether that be tire pressure measurement systems that go into four-wheeled vehicles, we even have them running in some two-wheel series as well. Most of our sensors can be used either for balance of performance, so they're dictated by series to make sure that teams are within their prescribed limits, but also obviously a lot of teams buy these sensors to manage and monitor their own equipment and their own vehicles. So I think I touched on tire pressure systems, which is a big thing for my team at the moment. We also make high temperature sensors, so they'll measure brake disc temperatures in any vehicle you fancy. We do boost pressure sensors that run in American car series. We do crank sensors. I mean, I think we've got the best part of 1,000 product variants within that team, just to give you an idea. Don't worry, I'm not going to reel them all off.
Wow, okay. It's a big catalogue of sensors.
It's a big old catalogue, and a lot of them are variants on other products. So, for example, we'll have a core product that we sell into many different areas, and the difference between one team and another might be the mounting boss, it might be the electrical connector, those sort of variants, or maybe even the measurement range on a rotary sensor, let's say. So there's a lot of variants, but we do have core product areas within that team. So I've been in that team a year, 18 months now.
And there's a few interesting things kind of come out of that. And obviously, regular listeners of the show will know, like we're normally talking quite intensively about electric vehicle stuff and hybrid vehicle stuff. And obviously Formula One is now all hybrids, and your ECUs are controlling the vehicle. But you see kind of more and more hybridization and electrification coming into motorsport from where you guys are sitting? So,
short answer, yes. I'm guessing you didn't want the short answer though.
Yeah, go
on. So I think it's always on the radar. Obviously, in the team that I'm within at the moment, High Performance Components, we talk to a vast range of series. We talk to a vast range of independent teams. And sometimes they always go, "Oh, are you aware of our electrical program?" I mean, there's a lot of stuff in electric vehicles. Tires is a great example. They've all got tires in motorsport, so they all need those. But I think, where you talk about the hybridization, there are definitely products that we are exploring and or have explored within our R&D environment that are lent that way, and we will always consider the requirements if something was to be fitted into a hybrid vehicle.
These are really complex. In some ways, it's sort of good in that it's pushing technology and things, but it's just lots and lots of extra levels of complexity with high voltage electrical systems and motors and inverters. You mentioned that McLaren are particularly involved in. So there's an awful lot of complexity in a race car now.
Yeah, and I mean we do products that are, current and future products that are specifically for hybrid variants. Like we say, we have to consider it, and sometimes a customer will come to us with a specific request. So I know the team that I work in, just as I started, we're just finishing off developing an alternator to go into one of the Le Mans cars, which is hybrid. So that's, from an alternator point of view, that's got some very different requirements compared to a what I would call a traditional alternator. Point one, simply because of voltage. And then obviously a core part of our business which is outside of the team I'm in at the moment, is the ECU world. And we are developing sort of our next generation of ECUs alongside of our standard ECUs that will run in many series. I know that one of those is earmarked for, I believe one of those is earmarked for Formula E. So there's definitely an appetite within the business to be pursuing those hybrid electrification series. Like you say, a lot of them are moving in that direction, either solely or in a hybrid variant. So they're not fully electric, but partially electric.
And I guess, so then the other part of how we led up to the discussion today. So again, some of the listeners to the podcast will know that I'm involved with a company outside the podcast called Transense, and Transense make torque sensors, have a special technology for torque sensing, and that is used by McLaren. So just be really interesting to kind of learn a bit more about how you're using those torque sensors in the driveline and where they come into it.
Sure. So I believe these torque sensors have been used within the high performance components team well before I was involved with this team. It's been an upwards learning curve, but predominantly our initial use of those sensors a long time ago was on the initial KERS, actually, systems that went into the Formula One cars. So it was about measuring the torque going in and out of those systems. And I think we did some of those for specific Formula One teams, or I suppose it's not specific for the team at that point. It's part of a powertrain package coming from a team. But really, the big one for us that has been on our radar for a very long time, I think over 8 years, has been IndyCar in the US. So the clutch shaft, which fits between the powertrain or the engine on those, because they're non-hybrid at the moment, between the ICE, the internal combustion engine, and the gearbox, you have the clutch shaft. And IndyCar as a series, we've designed those for the series. So IndyCar use that as a BOP, so balance of performance. So it's a way for the series to measure the torque output from those engines and make sure there's parity between the teams. So it's a sensor. So the shaft is designed, and it could work in that environment anyway without the sensor. So mechanically it's the same. And then we designed some features sort of in partnership between McLaren Applied and Transense that will mount those source sensors. And at a high level, those source sensors effectively vary their frequency output based upon the torque and temperature to an extent that the shaft is experiencing. There's a little interrogation unit that we design that the teams use, and that data is fed back to that McLaren ECU. And then that is encrypted. That data is encrypted to an extent so that the race series can see exactly what's going on with the torque coming out of that power unit, so that they can make sure all the teams are running parity. So that's the high level as to how those units work. And then we have started, we've just finished making a prototype, which is sort of the next generation of IndyCar drivetrains. So the fundamentals are pretty much the same. There's just slight different mechanical interfaces on either end. So still utilizing the source sensor, still used for balance of performance by the series. That's one of our more recent projects.
Doing that sort of thing, I know I've spoken to people about this in the past, and they're like, what, they can't quite imagine that it's possible to put a torque sensor into a real powertrain, that's going to go out on the track and get thrashed around. That's a pretty horrendous operating environment for a sensor like that. How have you managed to overcome all those sort of challenges in the operating environment?
Good question. I think the operating environment there is quite tough from a vibration point of view and a temperature point of view. These types of sensors, from a Transense point of view, have been used outside of motorsport for a number of years. So there's good history there as to their background and what they're capable of. And they're actually very small sensors, and they can deal with those environments very well. We tend to do levels of testing, whether that be on a dyno before they end up on real vehicles, to make sure that they're okay. We make sure we pick materials that we know are suitable in those environments, whether that be temperature or even fluids, for example. So the kind of fluids they'll be taken into account of those fluids. But actually that environment isn't, whilst we talk about that particular environment being quite difficult, it's actually not too bad there because it's not out in the airflow, it's not out in the open, it's not in the wild of the vehicle. It's contained within a unit almost. So as long as it's installed correctly and I suppose maintained properly and protected suitably during installation, it's not as difficult as it could be for some of our other sensors.
Yeah. It's you create a sort of a nice home for it in the drive line. Is it being the clutch shaft? Presumably, it's actually in the in the wet space in the transmission then.
No, it's in the dry between the two.
Okay, right. So in between the engine and transmission.
Yeah, in that particular installation, there's no reason you can't put that sensor on any shaft you fancy.
Yeah, and just going, actually, one of you mentioned earlier about the KERS. So just that's an interesting application. Because it's quite a while ago. Was that before your time, or were you involved in that stuff?
Definitely before my time.
Yeah,
it might have even been before my time as an engineer, to be honest.
Yeah.
But I should look at that actually out of interest and see if it was, because I think it will have been about the time when I graduated, but definitely before my time at McLaren Applied. But it does. You touched on a few things there that do make it interesting. And I was going to touch on some of the pros and cons, I suppose, of the source system versus other solutions that are on the market at the moment that actually make this sensor very suitable for a motorsport environment. There are a number of different ways to measure torque in a shaft, but a really important one, and I say it's important, is because it's not the chosen system at the moment, but it is a system used by a number of series or motorsport vehicles. Is basically measuring the change in magnetic field in a shaft as it experiences torque, which is used in Formula One cars, I believe. However, it's got some limitations, because it's got two key limitations really, particularly when we talk about this in hybridization and electrification. One, the shaft needs to be magnetized in order to do that, which is obviously not very good running near things like e-motors and areas where there's a lot of other magnetization going on. And the second one sort of falls out the back of that, which is it sort of therefore has to be steel. So those two combined, or sort of hand in hand, I suppose, are two things that we don't have to do with a source sensor. The shaft is not magnetized, so it can, within reason, be put on a shaft made of any material. So far, we've only really put them on metallic shafts, and I can't necessarily tell you what all of those shafts are made from. But yeah, there's no reason why we couldn't explore putting that sensor on some much more exotic materials than steel. Which, yeah, once again, I think leans quite heavily on this podcast, that it's a very useful differentiator of that technology compared to other solutions to the problem of measuring torque in high performance motorsport environments.
This is interesting. This we might have to sort of explain it a little bit more, but this balance of performance, BOP, That's becoming a really big thing, isn't it? It's like in different championships everywhere. So maybe just explain what that is.
Sure. Okay. So I think, like I said, our current most popular solution, if you could coin it popular, is the IndyCar system, and that's purely for BOP. So the series access that data to make sure that all the teams are compliant. And I'm sure your audience know that in any motorsport series you watch, there's often a desire for parity between machinery. And IndyCar is no different in that sense. So yeah, that's how that solution has been used up until now. We currently have a couple of projects that are 90% of the way through. I know that one of them, they've received early prototypes to dyno test on their facilities, and they are not BOP. So what's really interesting is with these source sensors, is that I think teams can see the value in the high quality of the data that come out of these, and they would like to use them for their own data collection. So there's this BOP market that we definitely want to still exist in and grow in, but there is definitely this direct data market as well that we're growing into, and the two of them combined can give us quite a good coverage over many series.
Yeah, it's interesting that with I just sort of people obviously can't see it on the podcast, but I'm smiling here because if you think of it, sort of like poacher turned gamekeeper in a way of the kind of gamekeeper turned poacher, because the BOP market is trying to control performance and stop people having a competitive edge, or doing things they shouldn't be doing. But then on the other hand, there's a decent market there for people to use this as a data source to give them a competitive edge. So it's a really interesting kind of like, I don't know, contrast, dilemma. I'm not quite sure what the right word is, but there's two different sides of it. Interesting if it started to become something that people could use, that almost like if people were using it to gain a competitive edge, but then if a championship said, right, well, actually everyone's going to have that from this point forwards, do you think the data would still give value to a team? If it became a standard feature, would they still be able to use it to get competitive edge on the vehicles?
I think so. I can foresee a situation where teams develop the system purely from a prototyping point of views, to try and help them. Whether that just there may be teams who just want them to run on a dyno because they're not allowed to run them in their series yet. We are in the process of chatting to a number of series to try and mandate them, trying to sell, like you said, trying to sell them on the advantages of a balanced performance, and that's not just for clutch shafts as well. We've been talking to series about balance of performance and individual teams about additional data in running them on drive shafts, for example. So post gearbox, so running two per vehicle, let's say, on the back end of a rear wheel drive race car, and there are many applications there, and there's lots of data you can pull out of that that teams can use when they're developing a car. I think there's a big lean for me towards, well, there's a lean in both directions, right? Not just BOP. There's a lean towards teams investing in that system for themselves, and we want to make sure that we're on both sides of that party.
Yeah, no, it's quite a cool thing, because from an engineer's point of view, and particularly motorsport, which is such a high speed development environment, you don't get a lot of time. Well, you literally get no time, because you're constantly developing the car, launching improvements, developing the next load of improvements, and being able to gather more data that says, is this working or not? I mean, that's a really valuable thing to have at your disposal, and often like actually measuring it to the level. You mentioned dyno work, and it's like chassis dynos are really difficult for people to use because of all the losses, so they don't tend to use those. So like vehicle dynos, and it's really difficult actually to do representative work and get good quality data from a lot of the points that you'd want to in a drive line with normal sensors. You can't just thrash around the track with a normal set of torque measurement equipment on a race car.
Yeah, and something you touched on there is one of the big challenges with any of these more complex sensors, let's say, is timeline. So a lot of series, for example, F1 will give you limited time to test, particularly on vehicle. And as you touched on, a lot of series will use dynos to try and do some development, but you can't argue with getting it on a track. There is no equivalent to that. And that time is limited, and it's very well prescribed and defined when and what you can do. So trying to get permission from series owners to run these effectively prototype systems in those events, but also to make sure that we're ready. These are not sensors that you just bolt on in an afternoon. They're designed into the component from the start, and the manufacturing lead times for things like drive shafts and clutch shafts at the moment is months, not weeks. And you have to know what the design is going to be at the front end of that. So sometimes you can be talking to series or teams, and actually there isn't enough time to get it done. So just because, well, this is when we've locked down this design, here are the changes that we're going to propose as McLaren Applied to be able to instrument that shaft. And then you can look at the lead times and go, actually, your season's not that long. There's your window where you've got to test halfway through. It's not really feasible. So the team that I work in are spending time on these source sensors at the moment to look at ways we can try and reduce that lead time, to try and make sure we're always ready and we can satisfy every customer who comes knocking at the door.
And I guess getting people to start thinking about it as well in a like, actually, if you plan this into your development program for next year, or it's something you need to be thinking about to plan in sufficiently in advance. You can't just kind of do it at the last minute. It's a real strategic move to deploy this sort of technology. Yeah,
well, if you imagine this shaft, so we've just spoken about the shaft itself, but alongside the shaft, you have what we effectively coin a static coupler. So this is effectively, imagine it a bit like a ring donut that the shaft sits inside. So there's a contactless pickup in there between the shaft and the coupler, and that's what transmits the data between the two without contact. That has to be mounted to something, whether that be a bell housing on a gearbox. So those things need to be taken into account with the lead times of the design as well. So there's so many little things to consider that are just outside. I mean, we were talking to a potential new customer the other week, which is what prompted this conversation I was just having then, about when we first introduced them to the system. It was that moment where they realized, wow, this is on a long lead time. It's not just you don't have a stack of 3 designs and we can buy one off the shelf and bolt it on. This needs to be thought about from the start. And there are benefits to that. It gives data way beyond anything we could think of that's just bolt on for now.
So then in terms of, how the sort of direction that championships are going in, more electrification, more hybrids, everyone's sort of either balance of performance or trying to get an edge. Is this something that you see, good potential in for the future for McLaren in terms of supplying this kind of sensor system alongside your electronics?
Yeah, massively. I think it's a great opportunity, and I think I happen to have moved teams at exactly the right time, I think, into this team. Some of the things they're doing are really interesting, but these source sensors in particular, tied in with the hybridization, the points I made earlier about the shafts not needing to be magnetized or made of steel, I think gives us a particular niche in that market, and it is well timed with the direction that market is moving in, and that's why I think we need to, and we are making sure that we explore as many possible opportunities for this, not just the clutch shafts, but also the drive shafts, also any shafts coming out of any hybrid system, anything that's used anywhere in the powertrain, not just internal combustion, are areas where we're exploring.
Yeah. Okay. And you can get more data, more performance. Sounds like a win-win all around. It's great.
Teams very rarely complain about more data.
Yeah. And the data analytics guys might do, but
we've had examples with one of these shafts in the past one of the early prototypes, and this wasn't a BOP example, it was a team example, and they've tested it and said, oh, there's quite a lot of noise on that signal. Is it right? And we've done a little bit of investigation and worked it out and realised that actually it was, I coined this in a non-engineering phrase, it was too good. So it was some of the spikes in their data that they were seeing they couldn't account for, but actually when they delved into the data a little bit more, they realised that it was actually the injection stroke on the internal combustion. So they were seeing things in that data that they were not expecting to see, which gave them the opportunity to actually explore other possibilities. So can we actually lose some of the sensors that we're currently running on our engine because the shaft gives us enough of an indication? So something that I didn't expect at all, just because of the resolution and the speed of the data, which is quite an interesting side of it.
So they could see the sort of cylinders firing on the engine. Wow.
Yeah, exactly.
That's phenomenal. So if we sort of, thinking about looking forwards, for McLaren Applied now, you guys, you're independent. What does the future look like for McLaren Applied?
Wow. So I'll deviate a little bit away from just talking about source sensors, I suppose, because we've touched on the future of those a little bit. So obviously, I think we've got those three key business areas that we spoke about before. So motorsport, automotive, and connected intelligence. And my knowledge on each of those lowers as I get further down that list. So motorsport is about really continuing what we do now. Be great at supplying world-class sensors into any motorsport series who would like them. There's a big focus for us about the standard ECU contract with the FIA for Formula One. So there's a lot of focus going into that for the moment, and that will last for a number of years, 5 years, let's say. And there's a lot of ancillary components that run with that. So, for example, we have a hub interface unit that works with that. So that lives in the corner of an F1 car, and all the data that comes from that corner, that's effectively a node that then the HRU feeds that back to the main ECU. So there's lots of little spin-offs from that, but really it's about continuing doing what we do now, but also making sure that we're there for the hybridization electric party, as you touched on earlier. So developing new generations of ECU to run alongside our standard ECU offering to Formula One. So taking that knowledge and applying it elsewhere, but also continuing to strive to make our high performance components better. We have a little bit of a motto within high performance components for smaller, faster, hotter. So whenever we redesign something, we need to try and make sure it's smaller. It needs to be able to deal with hotter environments, and it needs to be faster from a data rate point of view. So I think that's quite a nice mentality that one of the guys told me when I first started. It's very simple. It gives a clear message. You know where you're driving towards. Obviously, I'm a little bit biased because that's the team I work in. And then outside of motorsport, obviously we've got automotive, which is about applying that experience that we've got into the automotive sector. We're doing a lot of work with inverters at the moment, some particularly high power density inverters. That comes from our history of designing a number of inverters to go into the F1 powertrain teams that through necessity are high density. So taking a lot of that knowledge that we've learned and the expertise within our teams and developing them for automotive applications. I believe we've got some initial contract interest from some full electric vehicle partners. So these sort of inverters are not for hybridization; they are for full vehicle electrification. So that's a great market. Like you've said before, you and your audience, that's their focus, that's their interest. They all know what's going on with that market, and being involved with an inverter that's potentially the best power density of anything on the market to go into that arena is a great place to be as a business. I don't know a great deal about those inverters.
That sounds like it's a topic for a really good follow-up episode with one of your colleagues.
I'm sure we can recommend a few people. I can think of 2 or 3 already off the top of my head. But yeah, that would be a great topic to talk about with someone who is a little bit more knowledgeable about that technology than me. And then obviously we've got the connected intelligence stuff, not to miss out the third team, which I will hold my hands up is the business area that I know the least about, but they've got some some really interesting contracts coming up that I know I'm not allowed to talk about, that gives them real growth in that industry to really start. I think a lot of it's about volume in that industry, but really about them bringing something to the market that isn't offered anywhere else at the moment in terms of the communication and the data rates available on those types of vehicles, and really trying to throw some motorsport know-how. Technically, we operate across 3 sites in Woking. We also have an office in the States as well to help support our US-based customers, because there's quite a lot of them. But yeah, predominantly we still have a strong presence in McLaren Technology Centre in Woking, which is where racing and automotive are based. That's where we still manufacture all of our products as McLaren Applied. We have another offsite that does all of our machining, which I'm obviously more familiar with as a mechanical guy. So that's all the mills and lathes. And then we have an office in the middle of Woking to support those who don't need to be at a production site all day, every day. But yeah, we're still definitely present up at MTC. I still go up there as much as I can, because I'll be honest, you can't, in my opinion, as a motorsport nerd, I don't think you can beat walking past Ayrton Senna's cars or Mika Häkkinen's to go and get your breakfast. I don't think you can.
It's a quite impressive place, yeah.
Yeah, you get a little bit blasé to that, but sometimes you realise quite the environment you're in and how special it is. And I think that applies to a lot of people who work for McLaren Applied. There's a lot of people who have been here a long time. And I'm not saying the brand it's all about the brand, but that is a big part of it for them, the history of that team.
Brilliant. Well, and on that, which is probably a good point to bring things to a close, and I am looking at the corner of my eye, noticing that I've run over time again. So thank you for bearing with me. But thank you. That's been really interesting, Richard. Thanks for taking the time out to talk about McLaren Applied and motorsport and torque sensors and everything else. It's been really fascinating. Thank you.
No worries. Thanks for having me.